time shifts are more common. That is saying if a function has as its Laplace transform, f of t has as its Laplace transform f of s, then if we shift our input function to the right by some t naught, that's the same thing as having, in fact, let me even be clearer. We've already said that all of our functions that we can take the Laplace transform method of, you could multiply by u of t and not change it. Then, if we shift it, everything, every time you see a t, by t naught to the right, that's the same thing as multiplying our Laplace transform by e to the minus s times that shift. So let me just give another example. E to the minus 3t u of t. We know already that that has a Laplace transform of 1 over s plus 3. So what would happen if we shift this by 2 to the right? Now it's e to the minus 2s times the original transform. It only works if every place you see a t, you can replace it with a t minus t naught. So let's do a harder problem where you can't do that.
Sir, I have a question.
Shoot.
Where did the 2 come from? Like, is that just an arbitrary value you chose, or is that something that
comes from here? So every time it was shifted by 2, and that's why that 2 appears up here.
Okay, so you're shifting it by 2. That's something you
just like here, we're always shifting by t naught, and so we're going to multiply that s by t naught.
Gotcha. All right.
So let me give a harder problem where they're shifted by different amounts. Here we've got an e to the minus 2t u of t minus 5. Now, what does that transform into? So we don't know. Instead, what I want you to say is, if only we were asked this problem, then we could find it, right? Because then we'd pretend that it wasn't shifted at all. We'd say that's like this problem. And this we know as a transform of 1 over s plus 2. So therefore this, which is just delayed by 5, would have to be 1 over s plus 2 e to the minus 5s. But sadly, that's not what we're given. We're given something else. So the only way to see how to fix that problem is to take this guy and let's multiply through this first piece. This is e to the minus 2t, and that's e to the minus 2 times minus 5 is positive 10. So that's just an algebraic thing. Now, do we know what this guy's transform is? Anyone? Joe, do we know what this guy's transform is?
Isn't that 1 over s plus 5? Yeah, 1 over s plus 5. Or sorry.
Yeah, maybe my handwriting is bad. That's supposed to be a 2.
Yeah. Yeah, s plus 2. And then e to the negative
5s. That's right.
Yeah,
And we already,
5s.
because we already calculated it up there. So now this is true. Still not what this is, but can you see what you can multiply? John Arger, can you see how? John, are you with me? Okay, ciao. Can you see?
You can multiply the e power t.
Yeah, multiply this one by e to the minus 10, e to the minus 2t. Maybe I'm going to make it a little bit clearer here. We're going to multiply this whole thing by e to the minus 10. And when we multiply it by e to the minus 10, this e to the positive 10 goes away. And we're left with e to the minus 2t, u to the t minus 5 corresponds to a 1 over s plus 2, e to the minus 5s, e to the minus 10. And now we have this the same as our original problem. So now, therefore, this is our answer. And if you wanted to be kind of tricky, you could neaten it up a little bit by combining those exponents and say it's minus s plus 10. So that was a lot of steps we did. To make it clear, this was our first step, second, third. And then we started to go backwards for step 4 and 5. All right, I guess I didn't need to label those. They just go in order. Questions on that?